Galileo Galilei was born February 15, 1564, in Pisa, Italy. He died January 8, 1642, in Arcetri, which is now Florence, Italy. Throughout his early years, he was very into mathematics and became a mathematics teacher when he was in his late 30s and early 40s. And his first paradigm shift was using a telescope and finding how the planets, well, Jupiter, which is the planet that he found, had craters and sunspots on it. And before this discovery, people were using a Flemish lens to look at objects on the ground that magnified things far away. After reading about this, Galileo turned the magnifier towards the skies. Galileo made four main discoveries while looking in the sky: mountains and craters on the moon, four moons revolving around Jupiter, the phases of Venus, and the sunspots. And the main shift was before Galileo made these discoveries, everyone believed that the universe seemed to be made of materials and substance, kind of like the planet Earth. Also, Galileo proved that that ethereal substance made up the planet. He became the first European to make systematic observations of the heavens by using a telescope. It brought about a new age of astronomy. And today, the telescope is the main source for observing planets while on Earth. It has led to further observations that when NASA sends off astronauts and robots and other objects to the other planets, they take pictures. They also take rocks and and rocks back to planet Earth for experimenting. This is a little showing of Galileo looking at the stars.
All right. The second paradigm shift involved around the principles of motion, which in today we use in physics, and that it was the principle of motion was one of the problems that fell under the head of mechanics. The Australian conception held that the object remained at rest until the force was applied against it. And if some force was applied, then the object would move at a constant rate. But if it was removed, then the object would stop. And yeah.
So, as you can see, this concept had encountered some difficulties. Theorists solved this problem by arguing that the angle of air behind the projectile kept it in motion. Galileo made two contributions to the problem of motion. But first, he showed by experiments that if a force was applied to an object, then it would move at an accelerated speed rather than at a constant speed.
We use this in physics class.
Yeah, we use this in physics all the time. Also, Galileo discovered the principle of inertia. I'm pretty sure y'all know what that is because we use that in physics class as well. He used inertia by arguing that a body in motion continues in motion unless acted on by a force. And I could give you an example. Like, say, my hand.
No, use a car.
Yeah, like a car. If a car is going, it'll keep going unless acted on by a force, which could be friction, for example.
Or another car.
Or another car running into it.
Or if you have a person inside the car, it's like when you when you feel like you're turning, you're moving, like your body leans to the side.
Yeah.
That's principle of inertia because your body still wants to go in that
same direction, but the car stops it and makes it turn the other way with it. So this wraps up our project on Galileo. I hope you learned much information.
We love you.
Bye.
God bless.
Follow me on Twitter at iMiamiBoy.